Hey everyone, welcome back to another episode of the LlamaIndex webinar series. Today, I'm excited to host Didi Credo from CodiumAI, and the topic of today's talk will be on using RAG for large-scale generative coding. So actually, coding is something that is pretty interesting because we actually haven't really touched upon it too much in the LlamaIndex world. A lot of our data sources tend to be, documents, complex data, unstructured text files. But that's why I'm also really excited to host Didi, because today we're going to learn how do you actually do context augmentation for a lot of these coding tasks. How do you best, index a bunch of these coding files, chunk them, and then use them for context augmentation. So with that said, passing it over to you.
Great. Thanks a lot, Jerry. Thanks everyone for joining today. So I'm Dedi. I'm the co-founder and CPO of CodiumAI. We are an AI coding assistant company, and we focus on code generation, but with a big focus on quality and code integrity. So really a lot of our IPs around testing, code review, and really combining enterprise best practices in everything that we do. And for that, we heavily rely on RAG, and we found it to be extremely effective for coding use cases. But as Jerry started saying, using RAG for code requires some specific techniques and tricks, and I'm going to try to cover a lot of that today. And I'm going to just say right off the bat that we use LlamaIndex. That's kind of the basis for what we do with RAG. So yeah, we love LlamaIndex, and we're very excited to partner. Great. So in terms of agenda, I'll start with just a very kind of like 101. What is Retrieval-Augmented Generation? And I'll touch on it with the context of coding. I'm going to talk about strategies for applying RAG to large-scale code bases, specifically around chunking, embeddings, and then how we do the re-ranking and filtering process. And then I'm going to finish with a quick demo of RAG in action inside of our product. And feel free to ask questions in the chat during the session. Let's make it interactive. And Jerry will kind of read the questions, and we can make it interactive this way. Perfect. So first of all, what is RAG? So I'm sure like probably most of you know it, so I'll just go through it very quickly. The idea here is that LLMs have been pre-trained on a bunch of data, but it's not your data, right? So what we do with RAG is that we pre-index a bunch of documents. In our case, it's mostly focused on code files and typically on a set of repos in the customer's organization that we do through integrating with like GitHub or Bitbucket or GitLab in most cases. So there's a bunch of documents. We need to chunk them into logical chunks of code. Then we generate embeddings, essentially a series, like a vector, a series of numbers, vectors in embedding space, and that gets saved in a database, which is called a vector store vector database. And then at query time, we take the user's query, we convert that into an embedding, and then we also augment that with additional information from the user's code base. So this can be maybe the function that they're asking about, or maybe some sections of their file. So that all becomes an embedding that is then used in a similarity search against the vector database. And then a set of code snippets or chunks get retrieved, and then they're being fed into the model together with the user query in order to generate the final answer. That's just at a very high level. So why is this important for enterprise-grade code generation? First, we want to ensure the quality and integrity of the code. So if you have your own libraries or your own set of repos that you're using, you want to make sure that the answer takes those into account. It can either be your existing project that you're now like your current repo that you're working on, but it can also be things that are coming from other repos of your organization. And that way we can also improve the efficiency. So you're not getting generic answers from the LLM, and then you have to kind of customize it or then adjust it. The idea is to minimize it, like the adjustments that are needed from an answer that's coming from an LLM, either in a chat or in a code completion scenario. We want to avoid duplicated code. So the ability to search the code base, and then eventually have better maintainability of the code. And then we want to also encourage developers to use best practices of their organization. So use the libraries or use their the different capabilities, especially in large enterprises, to combine those best practices in the answers. Okay, so in terms of the, or maybe I'll pause. Are there already questions in the chat or what I showed so far?
What are, maybe you're going to get to this later, but
yeah.
What are some of the top level UXs that you could see like context augmentation being used for? Like what are some of these like end use cases?
Yeah, so the top one I would say is Q&A. So that's like our chat interface that is inside of our IDE plugin. So we have an IDE plugin for JetBrains and VS Code. And in that plugin, there is a chat interface. So that's one major area. Then we also have additional kind of UX for generating tests also inside of the IDE and combining results from RAG. So for example, if you're trying to generate a test for a given class or function, you may want to bring in additional supporting information from the repo or from other repos that could be relevant. And then that's being used in the test generation piece. So that's another major area. And then a third one I would say is in our Git plugin that is integrated with, for example, GitHub. So inside of the GitHub interface, when you ask a question on a pull request, you want to have RAG embedded there as well.
So now you might be getting to this in some of the future slides, but is the context augmentation, the retrieval part different? Like, do you create separate pipelines for each of these use cases, or do you create some like shared underlying backbone?
Yeah, it's pretty shared, but what we embed might be different. We may have at some point, like we're going to do different pipelines, but at the moment it's pretty shared. And the difference is like what you embed. Like you would embed for testing, you'll have a different a set of code that you're going to embed versus like in a Q&A scenario.
Oh, interesting. So you have like different source data for that.
Exactly.
Okay, got it.
Cool. So at a high level, this is like the pipeline that we do for the indexing part. So first, we need to retrieve the file from the code base. There is a set of supported files that we filter. So for example, we may not support like some obscure file that we don't know how to handle. Then we have different splitters that split in the code into chunks for code, for text. And then there's some dedicated use cases, dedicated splitters and chunking strategies that we have for different use cases. And I'll touch on that in a few minutes. We also generate descriptions of the code. So that's another like a cool thing we recently added, and we found it to enhance the quality or the accuracy of the results. So we don't only index the code, we also generate a description of the code using an LLM, and then we index that as well. Obviously, that's we convert it to embedding, and then it gets saved in the vector store. We currently mostly use like Postgres as the vector store. Okay, so let's go into a little bit more detail. Like first, let's talk about chunking. Okay, so obviously for natural language, the strategy around creating the chunks is more straightforward, right? You have clear paragraph, you have boundaries between sentences, and that's pretty generally pretty straightforward. For code, the naive methods struggle because like there's all these different constructs in the code. There's boundaries, there is classes and functions and methods. There's the imports part typically at the top of the code. There is the constructors. So you may want to handle these differently, and for different languages, you may also have different strategies, and that really impacts the performance. Like the more cohesive the chunk is, and the chunking strategies are, the better the accuracy and the results. So what have we done? So first of all, we're using LlamaIndex, and the basis for everything we do, or how we started, was like the method that is being used using concrete syntax tree parsing. This was open sourced by Sweep AI and was adopted by LlamaIndex, and it's using another open source called TreeSeeder. And it's a really good basis. Okay, it's like really a really good basis to start from. And then we started from that, and the nice thing about it is that it works pretty much for any language. Like it has kind of like a standardized method. But once you want to start like really pushing the quality and the accuracy of the results, and like being able to focus on specific languages, creating specific strategies for those languages, and then also add additional metadata or more advanced strategies for code chunking, that really helps to increase the quality and reduce hallucinations.
Maybe before we get into the improvements, I was curious if you're able to just give like a quick overview of that tree sitter algorithm, just to give the audience like a general understanding in case they haven't heard of it.
Yeah. So tree sitter basically, it's a syntax tree parser that was open sourced. I believe the source of it was in GitHub, if I remember right. And I'm not an expert in it per se, but it does provide a really good baseline for parsing different languages. Like it automatically recognizes the constructs, the loops, the if statements. So it helps you to generate more cohesive chunks as kind of a really nice baseline. Okay, so let's talk a bit more about more like intelligent chunking. So first of all is language specific chunking to respect the structure of the code and relevant and keep relevant elements together. You want to have the chunk sizes a bit more flexible and try to provide like critical context and add that to each chunk. So for example, if you were to put a certain method like in a Python file, for example, and you would want to put it in one chunk, like you would want to try to add, if possible, the constructor of the class and the imports, right? Because that really helps the model to then get that context, that additional context, and generate a better response. Then the last aspect is for different file types, you may want to have more advanced or very specific strategies. So I'll give another example. Think of like an OpenAPI file, like a Swagger file that has different endpoints. Instead of like chunking it generically, like you may want to chunk it by the specific endpoints to keep each endpoint in like one chunk that includes all the parameters, the responses, and the security definitions for that specific endpoint. So for that, you'll need to build a specific kind of processor to process the file, to identify those endpoints, and then to chunk them specifically in a different way, or like keep them like cohesive. So for that, we started a lot of it is coming from our customer base, the requests for these use cases, and then we see how the standard methods work. So for example, if this open, like in many cases, these like are YAML files, for example, these spec files. So we've tried with like a standard approach for a YAML file, and then we saw that after we've implemented a more dedicated strategy for OpenAPI, the results or the answers in the chat were much better. Okay, and we have different.
Oh, sorry. Yeah. Just double clicking into the flexible chunk sizes a little bit. I think it's very interesting that you mentioned that you inject metadata like the class definition and import statements into each chunk. And so actually just kind of seeing, okay, I guess you're giving some examples. So maybe my question's redundant as well. But I assume for like a function, for instance, within a class, you try to preserve that as like a cohesive chunk generally, but then like for each function, you try to inject like the relevant metadata on top, or I'm curious how that works.
Yeah, exactly. So like if possible, obviously, like we can also keep the entire class in a chunk, like depending on like the kind of the limit size that we've defined. And then if it doesn't fit, like let's say we'll say, okay, so then we'll take like each function or method, each method separately. But then we don't want to only index the method. And that's what actually the outcome of just using the sweep AI with the current LlamaIndex process. It will give you something like this. So it can actually break down and keep like a method in a chunk, but this is not enough for that chunk. We want to add the constructor, the init method. We want to add additional imports. We may even add additional like signatures of other methods if they can fit. So like the model that then will get that chunk into a query, the model will have better context. It'll see, okay, there is this str class, str method, and it's part of the complex number class, and these are other methods that are around it, and this is the imports. So that's like so that's what we found that is helpful, and we've done those. We've added several languages that are kind of the top languages that we support, and we have a fallback, right? So if it's a language that we do not have that implemented yet, we will fall back into the standard, LlamaIndex, sweep AI based like chunking.
Super interesting. And have you ever noticed that you might like? I'm just curious from your experience that you use a different embedding representation or like representation used to embed the chunk versus to actually synthesize over it. So for instance, like I wonder if, for instance, you ever experimented with like extracting out like a doc string or some sort of semantic representation that's more suitable for embedding and retrieval versus, filling in all the metadata so the LLM can synthesize over it.
Yeah. So that's like the next slide.
Okay, nice.
So
Great.
basically part of the process that we do is when we index, before we index, we generate a description for each code chunk. And that gets also an embedding. So we enrich the embedding with the actual, free-form or like natural language description of the code. And that helps, and we can index that and embed that. And imagine this like same embedding can potentially point into the same code. So when a user like writes a query in the chat, maybe it will just like fit the embedding and it will match to the right code, but maybe it will match to the text, and the text will point into the relevant code. And so that's like that's how we do it. And we did find that this, yeah.
Oh, sorry for cutting out. The embedding representation is actually a representation of extracted like natural language, basically.
Yes, both.
Okay.
So we embed both the code and the natural language. Yes.
Makes sense. One of the questions from the audience while we're here is, do you look at using LLMs for chunking at all, or do you find that just heuristic-based, like file-specific chunking works well enough?
Yeah, we are using LLMs in a later phase of the process to do the filtering and re-ranking, and I'll touch on that when we get there in a minute. We haven't experimented with using an LLM to actually do the chunking. It's interesting, definitely an interesting idea. Yeah, it can see how it can work. It will take a lot of like a lot of compute and time and like to do that, I think. But maybe I can think of ideas of how to reduce the latency or tokens. But no, we use like the nice thing about code is that it's parsable, right? That's the cool thing about using tree-sitter and using language-specific parsing, that you can do that. Like you don't really need the LLM for that. And it's a question like of how much boost in like performance you can get versus the cost the cost and the latency that it would cause in the process.
Yeah, totally. Especially with code being like a pretty structured format, you might as well get like deterministic guarantees instead of having a stochastic like model potentially error out on some edge cases.
Yeah. Cool. Any other? I see there are a few more questions. We want to tackle another question.
I think one of the additional follow-up questions here is what embedding model you use to embed code or just embed this representation.
Yeah, we use like a standard, like mostly like the OpenAI, like as of today, like I believe the large 3 or 3 large or whatever it's called, like the newest. We did before that we used ADA v2. We didn't find a huge impact in performance when we switched to the new one. But yeah, that's what we do. And for self-hosted deployments, we also support like air-gapped self-hosted deployments. And for that, we're still experimenting which embedded model to use. So we're trying out different ones. Yeah. And cool. Okay, so this is the retrieval, the retrieval and ranking process, like at query time. So I go back to the example of the user writing a question in the chat inside the IDE for a specific, like with a context that has like some code that is part of that context. We embed all of that, and then we use that with typical similarity search to retrieve. But depending on the different embedding model, you have to set different thresholds for like the similarity, right? So that's also something to tune. But then you basically get a set of chunks that get retrieved. I would say like a few tens of chunks is typically like what we would retrieve in a typical user query. And then there is the filtering and re-ranking process. And that's where we use an LLM. And we found that to be extremely useful to actually give the LLM the user query and the retrieved chunks, and then filter out irrelevant chunks and reorder them. And the nice thing about it is that the LLM can spit out an answer that is very short. So it can be like just the numbers of the chunks that you want to keep or something like that. And then so that process doesn't take too long. It does add latency, but it doesn't take too long. And then you'll need to parse the answer of the LLM and then accordingly to filter. And because if you just take all the chunks from that were retrieved, you can confuse the LLM a bit because there will be some irrelevant stuff. So if you ask the LLM what is relevant for this specific query, and then you do the filtering, and then you do the last step of actually producing the final response on the selected chunks, and that final response can either be like answering user query or generating tests or whatever the task is, or doing a code review. Now, that's that approach we found it works quite well.
So I'm curious how deep you get into retrieval, and as always, you might be getting into this in future slides. Because in my mind, especially for code, it seems like because you basically are parsing out like almost like a graph of like dependencies, like a function or a class can have dependencies on like other functions. There's maybe there's like potential opportunities to use stuff like graph-based retrieval where you further explore like entities, relationships, like going from one function to another. There's also like maybe hierarchical retrieval where like, you have top level classes or like top level modules. And then within a module, you have like, underlying definitions and then underlying API specs. And so it seems like given the nature of the question, you could retrieve out like different levels of granularity and actually have like different ways of filling the context window. But curious like how you think about that.
Yeah. So yeah, like it's not showed here in this chart because I'm focused here on the RAG example, but definitely we do using like parsing and inside, for example, in VS Code or in JetBrains, like we definitely bring in we spend a lot of effort on collecting the relevant context. So we will actually kind of go through the tree and we'll bring in additional code that is using that specific code, and we'll see the imports, and based on that, we'll bring additional code. So we do all of that, and that gets combined with the RAG, like the results that are coming from the RAG.
So yeah, and actually for instance, for the Copilot use case, for like, let's just say you're trying to do autocomplete, given kind of what the user is typing, you probably want to stuff the context window in a variety of different ways, right? So one is based on retrieval from like your knowledge base. One is probably just based on, my understanding of how like any sort of Copilot works is you just take like the last like 100 like, characters or lines or something, you just stuff that into the window as well. Is that something that you guys do, like almost like a multiple retrieval or context window stuffing type approach?
Yeah, we have like a strategy around it. So we would look at the so for for code completion, it's like you said, it's combining things like the information from the project, right? And this can be with RAG. This can also be information that would include like the project structure, the files that are in the project. There's information that you can bring in from open files. Then there is like a window that you want to keep of like above the cursor and below the cursor. And there's different strategies around that, how much you want to bring. And then it's about like giving a specific model and a specific like a context window that you want to fill. You build a strategy around that of how much you save for each piece, and obviously if you have leftover, you can use it for other areas. You give priority essentially to. So for example, code completion, you really want to give priority to the code above the cursor. Like the immediate code above the cursor is the most important thing that you should have. But then there's different strategies around what you prioritize next, the code below or other files, or so. So that's like, I would say that for us, like in terms of the history of the company, we started focusing more on testing and unit test generation. Then we expanded to code Q&A, and we added a chat, and we then also added the Git plugin, which we call PR Agent, that is also very unique to us and helps with code review. And then code completion is kind of like one of the last things that we've added. Like it's interesting, most like coding assistant companies started from code completion, and we're recently like added code completion. So it's like it's like a newer component, I would say, in our stack.
Makes sense. How do you think about like the amount of context that you want to stuff into the context window? For instance, let's say you're generating like a unit test. It's possible, if you just do like if your top K is not high enough and you just do vector search, you might not actually get back all the relevant pieces of information about like a certain class. And so maybe you just want to stuff the entire file. And I'm curious how you think about that.
Yeah, it's still like an ongoing experimentation and tweaking that we do based on results that we see and benchmarks that we have internally. I would say it's still like an area that we experiment with a lot. It used to be like, when we first launched, there was no GPT-4. It was just, everything was GPT 3.5. It would get confused really quickly when you give it a lot of context. And as the models are getting better, and they're getting better at also handling the long context, we started moving towards like expanding the context and leaning towards adding more than less. But there's still cases where we see that like we add too much and it does impact negatively. There's also, you want to have the right context, but not too much context for code. So yeah.
Yep, makes sense.
Cool. Okay, so additional things that we're working on. So introducing like things like the notion of capabilities, or like kind of a domain specific filtering. So imagine like a large enterprise that has a set of capability that has different teams, and maybe different teams will need to have access into different set of capabilities inside of the organization, and those capabilities can be mapped to several repos sometimes. So you may have like additional level of filtering. So this is the user, this is their business unit. Based on that, you can auto filter certain access to certain like repos or certain vectors, and also give the user control. We also find that the concept of kind of golden repos for enterprise, especially for, again, for large enterprises, works really well. Basically, you don't index the entire enterprise code base. You index specific repos that are kind of defined as the gold standard, the code that is vetted, that is of high quality, that has usage examples in it, and that helps to increase the quality when you do retrieval. And then benchmarking and evaluation is also quite challenging. So that's an area of, ongoing research and ongoing experimentation that we do. Luckily, we have some really good design partners that are helping us, and they're testing on their specific use cases, and they can help define benchmarks, and we work very, very closely with them. And then we can see, like, we make a change to the filtering strategy, or to how we do the chunking, and then they have a set of predefined queries, predefined questions that they can run. And it's also quite nice to use LLM as a judge for that. So you would have like an example of a good result, and then you'll have the LLM kind of judge if the new result is really deviating from the good result. So that's on that. Yeah, was there? Sorry, were you going to ask another question, Jerry?
Yeah, I was actually just curious when you mentioned this repo level filtering. Like, is this during query time, or is this during indexing time? Like when the user has a question, you try to filter down for a relevant repo first.
So at indexing, you'll have to save the metadata of, so this repo is, let's say, associated with, like, for example, this business unit or this high level capability. Let's say a common example, an organization have their identity service. Like, think about a large software company, and they have an identity service. So they want their developers, when they query and when they write a question about identity, about how do I authenticate? I'm building an app and I want to include authentication. How do I do that? So before indexing, like, you already associate that repo with a tag of identity. And you know that user has access to identity, for example. And it could be that, like, there's a certain business unit, a vertical kind of business unit that has a set of repos that are associated with their capabilities that their developers are working on. So a developer from that business unit, it can either be implemented by having a filter on the metadata, so you save with the chunks the metadata, or you can have a different vector, like a complete different, like another table in the database, right? So there's different strategies to implement that.
Gotcha. Now, following up from some of the questions in the chat, there was one that I just want to get to, which is related to an earlier slide that you asked, or that you talked about. The question is basically, when you extract out the code descriptions from like a function or class for embedding, do you embed the code description and the code itself in like separate indexes, or you like combine them and then generate an embedding?
Yeah. So you can do both. What we do today is that we do them separately. So you'll have one embedding for the text, one embedding for the code. And then at query time, when the user asks a question, it might match with either one, but both of them point to the code. So then you will retrieve the code. Maybe you will retrieve it twice, and then in the duplication, you will reduce the duplication. But you can experiment also with doing them together. Like we found that separately works a little better.
And then the next question is on evaluation, actually, which I think you touched briefly upon. But obviously, LLM as a judge is a pretty common evaluation framework. It seems like for code, there's maybe some special considerations or ways of evaluating that are different than evaluating over like a document, for instance. For instance, I think someone in the audience mentioned like a code interpreter, right, to run it, to basically just understand whether it runs or not. And then I'm curious, in your mind, like what are some of the evaluation metrics or criteria that you look for?
Yeah. So this is very early, like still, I would say early days for us on that. Like we're still experimenting with that also. What we found is that in our use cases, it's not necessarily code that will just run off the bat, because it might be like a just a some textual answer and then a code snippet, and you want to identify certain areas of the answer that are important. So for example, you can have like one question, and then an answer, and you know that answer has to include certain parameters in the code that are important. And then you give them to the LLM as a judge as part of the like the exercise of being the judge. So you look at here is answer one, it's the good answer. Know that it has A, B, C in it. Now look at the new generated answer. Evaluate how far it is from give a score of how from 1 to 10 how different it is, and does it have those 1, 2, 3 things that are important. That's what we found that works for us for these enterprise use cases, but for other use cases it might be different.
Cool, thanks.
Yep. Cool. Okay, so this is like, I guess this is my last slide. So this is just like a little bit about us, what we do at CodiumAI. So basically, we have a set of different agents or a set of different tools that we provide. I mentioned like our IDE plugin, which we call CodiumAI, that plugs into JetBrains and VS Code. And then we have PR Agent, which is our Git plugin that would plug into the different Git providers. And then we have what we call the controller that includes the indexing. Okay, so that's the part that we also have local indexing in the IDE. So if you just download and install CodiumAI today, you can already use indexing locally. But for our enterprise offering, we have kind of a centralized indexing service that is then being used across. We also recently launched a new open source called Cover Agent, which automates generating regression tests, and it actually runs them as part of the process and measures like increase in code coverage. It's kind of a really neat. It's a newer tool. It's a pure open source. We don't even have like kind of really a paid offering for it yet, but it's like quite nice. You give it like a file, and you give it an existing like a test suite and a code coverage report, and then it starts generating tests and tries to increase the coverage, reading the code coverage report and running the tests and throwing out the tests that fail and keep the ones that actually pass and increase coverage. And then we have others like agents that are in the roadmap. We want to integrate with like, for example, a Jira to bring in the spec of features, and that would feed into our controller. And we recently launched like a more detailed like reporting and insights component. And then from a models perspective, we support like a variety of models. As I mentioned, like in our SaaS offering, we use primarily OpenAI, but we're now adding the option to also use Anthropic. And for self-hosted deployment, we have our own fine-tuned model, which is basically like our fine-tuned version of open source models. So this is like our platform. And what I wanted to do next is like show a quick demo of like some examples of RAG. But maybe before that, we can pause if there are a couple more questions.
Yeah, I mean, I think there's like an entire, probably separate webinar worth of content on kind of how you built these agents. Maybe just the general question I would ask is, how complex or like advanced are these agents right now? Like how much explicit constraints do you set on the behavior? How much human in the loop do you have? Like how many minutes basically can you wait before like trusting that it gives back a response?
Yeah. So yeah, as of today, they're quite deterministic, I would say. They're less agenty, even though we call them agent. We are so what we're doing is we're building a lot of the core capabilities, and then the kind of the more like agent base that will include more tool usage and things like that. Those are things that we're now actively adding. We recently introduced like one agent that creates that helps to plan for a new coding task inside of the IDE, and it generates a plan for you. But definitely there's a lot more to do. Like we do a lot of work on testing, and what we are planning to do is to actually have an agent that has testing as a very core capability of the agent, so that you can use the testing like to do kind of like more TDD style like code generation. Yeah, out of all of them, I would say that the most agenty agent is the cover agent. It's the newest one that we released that like has more like iterative process of like generating tests, running them based on the outcome, like figuring out if it's like increase like should it keep the test, should it not, should it generate more, like that has more autonomy. That's the one that has the most autonomy, I would say, at the moment. Cool. Maybe we'll show a quick demo.
Yeah, I'm
We
excited.
can take more questions. Okay, so let me do this. I think I shared my entire screen, so I think you can see my VS Code now. Is that correct? The correct statement? Okay,
Yeah,
cool. So I'm in VS Code. As I mentioned, so I have CodiumAI installed. Like to install it, like you just search for CodiumAI in the VS Code marketplace or in the JetBrains marketplace, and you install it. Here, this is actually our code base that I have here. I have some util functions here, set of util functions that manipulate strings. And here I have the CodiumAI chat open, okay? The first step that you do when you start working with the chat is to select the context. So we're quite flexible in that. You can either focus on your current file, you can focus on your entire diff, which is quite useful. So you can say, hey, I want to focus on my stage changes or my committed changes or whatever. You can also add extra context. When you do that, it actually indexes your project. You can either index the full project or search and index specific files or folders, and that would maintain a local index. So if I click here, full project, for example, you see it's now indexing, and now under extra context, I can see that this was indexed. Okay, and I can remove that. And then I have a set of commands that I can run. If I hit slash, I'll get a list of commands that I can run, a set of pre-built commands. Or I can just write like free text like questions. Okay, so I'm gonna actually start with that. So here I already have kind of the chat focused on this utils file, and it's focused specifically on this limit lines function. Let's actually start by running a /explain command to see what this function does. So I write /explain, and that will take this limit lines function, review it, and will generate kind of a structured description. So now it's not like really doing like a RAG per se, but the idea here is to just show you guys what it does. So the explain command gives like a really nice structure of the function, the example usage, inputs, flow, outputs. So you can see it's a function that takes in a text and then max lines and direction arguments or parameters, and then it would trim the string either from the beginning or the end based on the direction and the max lines that I gave it. Okay, quite simple. So now I'm going to do something like this. I'm going to say, hey, find similar functions. Okay, so this environment that I'm here is already connected to our various repos that are pre-indexed. Okay, so when I ask this question, the model now does a vector search. It converted my question, so this query, find similar functions, and you can see the context, this limit lines function, and it did the embedding search and the whole process of bringing in the additional the retrieving different code snippets or chunks, and then filtering them and everything, and then producing the final answer. So in this case, you can see it found another function called clip tokens. It's highlighting the similarities, the difference. It's showing me the different functions. And then I get a set of references at the end. So you can see that it brought in information from the PR agent. It's another repo we have for PR agent. Another, a few more references from other repos. And I can see the different chunks that were used. So there were a total of 4 chunks that were retrieved in this search. And I can give it more complex instructions, obviously. Like I can say something like, not only find similar functions, but also refactor and refactor limit lines based on the best practices that you identify. Okay, so that's going to do, it's a similar process, but now I'm not only going to get the relevant functions, I'm getting like kind of a refactored version of my limit lines with an explanation of what are the additional enhancements that were done to it, as well as the references, as I can see here at the bottom. So yeah, that was like a quick demo of this, of using RAG in a coding use case.
Super interesting. Quick question: when you do a slash command, does it just inject stuff into the system prompt, or like, because I guess technically you could also just do it through natural language, right? I'm just curious, like when a user would use a slash command versus just like prompting the model.
Yeah, you can do both. You can do either, basically. The slash command has a designed set of, it's not just a prompt. Sometimes it's actually multiple prompts and a process. So for example, if I will do a quick test, let's do slash quick test. Quick test is meant to generate like a few unit tests. Typically, it will take like a happy path edge case or a happy path or a couple of edge cases. So it has kind of a predefined prompt. It also has a slightly different strategy around the context. So it may bring additional relevant context that we think is more relevant for testing or for mocking. So that's another example. And then there are certain commands that have a completely different user experience. So I can show another example. Like for example, /improve reviews the code and tries to find specific areas that can be improved. And it actually gives a whole different experience or UX. So you see, it gives you this little, these different recommendations. For each one of them, I can expand and see more details. And I can select a specific recommendation or even a few, and then prepare the code changes, and I'll get kind of a diff view. So I can see the diff. So there's like a whole different kind of experience around it.
Yeah, this makes sense. I actually think this could be an interesting opportunity if you're thinking about feature extensions for, or you might already have this or have built this, but like for some sort of dynamic agent reasoning. So like if you enter some like higher level task, like, oh, first, I don't understand what this function does, explain it to me, then like refactor, and then, like try to push PR for it. Then it can like, have an agent that generates a plan for you that actually executes some of these commands, do some human in the loop so that you verify it. And then you basically then launch the entire thing.
Yeah, we actually have a starting point of that, or like kind of a very kind of, I would say, alpha-ish version of like a task planner. So I just opened another project to show this. So here I have like this is a web scraping tool called AutoScraper, written in Python. And let's do this. I can add this entire thing into the context. I can either like add it through like a RAG with like extra context and just add a full project. I can also just select the code. It's another way to add context, and do Command-Shift-E. And then it adds the entire file into the context. And now I'm going to do new task. And let's say I want to add new functionality to AutoScraper. Let's say to scrape Google Maps. Okay, so now the task planner is kind of I would say it's like an initial agent that is set to for this. It's designed for that. It will, first of all, it knows to ask for clarification if it needs to, if I didn't provide enough information, which obviously I didn't. So it would request information. So you see some missing information here highlighted. And then it will start listing out steps. So these are the different steps and the different files that should be adjusted. And I can see that like it will give me the code snippets. It's still not quite, it wouldn't like run, like actually add that and run tests. So the next step we want to do here, but it does give me a full, like a really nice set of steps. And obviously I can also see the references here. I can adjust it, so I can kind of open a thread and interact with it and tweak the plan and adjust the plan. And I can also edit. And another thing that is kind of, I think, pretty unique to us is we've added the ability to add that plan into the context of code completion. So that's quite useful. Like imagine like you're starting your week, you're working on a new task, you're adding, you got kind of a nice plan that you're happy with, then you add it to the code completion, and that now it sits in the context of code completion. So when I go and do code completion, and I would do like scrape Google Maps, the completions that I would get, oof, it's not what I expected. Okay, sorry, the demo effect. Or maybe I have the wrong model here defined. Okay. So yeah, the idea here is that it will use the context to provide the completions.
Makes sense. So you basically, given that context, given the plan, you actually just directly write the code for you in the IDE versus just generating in the chat window.
Yes.
Gotcha.
Yes, it's like you can still write the code. Yeah, like you'll get like completions that are more aligned with like the higher level tasks that you're working on, because it knows your plan essentially. Yeah, we have, so I showed a little bit, like we have more advanced like capabilities around testing. So like I can click test this class, and we also use RAG for that. So we map the entire set of the entire behaviors of this. So you see in the context, some of this is coming through parsing. Like you see the information coming from the utils files, for example, that is relevant because it's coming. You see it's coming here from the imports, and then in here you get a set of behaviors, happy path and edge cases that enable the developer to kind of choose what you want to test, and then some initial tests. And yeah, we do have some kind of agentic capability here as well, where you can kind of run an auto fix tests. So if I do that, in this case, they pass. Maybe this will fail. No, it passed as well. If it fails, it would kind of reflect on it. It will try to learn, and then we'll try to generate another version of the test. And then I can just generate more tests if I want to for different cases. I can drill down, generate this. It basically adds those to my test suite. You see they get added here. So yeah, RAG is obviously RAG, and also like additional sources like language parsing is combined here in most of everything we do essentially here in the IDE.
It's awesome. No, this is a great demo. I mean, it was really comprehensive. And also, I think you basically gave like a full tour of the different possibilities and use cases for retrieval, which I think it's important because I feel like a lot of people, when you first build RAG, it's mostly a chatbot over your documents, and it's clear that this is like a foundational module in a broader agentic workflow for a bunch of different use cases, right? Whether it's generating a plan, like refactoring something, or generating test cases. I think this is a good stopping point, actually. We're nearing the time, and so yeah, thanks, Eddie, for a fantastic presentation and also educational workshop on how do you do chunking and retrieval. Hope you enjoyed it in the audience, and if you joined late or couldn't make parts of it, this will be on YouTube as well. So with that, we'll see you next week. Bye, everyone.
Thank you very much. Thanks, Jerry. Thanks, everyone. Bye-bye.